Right, welcome back. We're going to have a look at the trigonometry part of the tutorial 6 now and see what we can work out. Alright, so for each of these, it's only asking for the sign of that means plus minus. So if we do our exact values trig Cartesian coordinates, what we'll be able to do is have a look at cos 89. So cos 89 will be just short of cos 9, so very narrow triangle, and cos is looking at this part here. Cos is positive. 169 is just short of 180. So in this case here, it's looking at the sine. There it is. And the sine is positive. Okay. Now the tan of 289 is 290, which is greater than 270. So it's all the way around here. And that's how we would draw that, 270 going like that, 289. So the tan of that is to say the opposite and the adjacent. So the y value is negative, the x value is positive. So that means that y rise over run is a negative over a positive, which overall is a negative. So that's a negative. So we're just using our techniques of recognising association of y and x. That's all it is. Now sec's a bit tricky. Sec is cos. So sec is cos, but it's a cos 160, now 180. So 160 is going to be here somewhere, like this one. 160. I've exaggerated a little bit. 160. Bit short of 180, but less than 169 that we did before. Now, the cos of this is negative. The x is negative. Okay? So whether it's 1 over cos or not, it's a negative. Tangent will be a bit trickier, but even so, at 239, it's now in this. 270 is here, so it's somewhere here. 239 is somewhere here. So we can see that y is negative and x is negative. X is negative as well. So they're both negative. So that means that regardless of whether it's a tangent or a cotangent, it's minus and a minus. So they're plus. And cosec is sine upside down. Now 211 is going to be somewhere here again. 180, 211. So 211 is going to place it here. So the y is negative and the x is negative. The y is negative. The y, 180, so it's a bit further. But it's the reciprocal of sine. So the reciprocal of sine will make it a positive. So a positive and negative will make it a negative. That's all that is. Just a simple recognition of what's going on there. Alright, a ray or line passes through 0, 0 and 2, 1. The angle between this ray in the positive direction, without a calculator, find sine and cos. Okay, so let's put that here. So we've got our 0, 0. There's our origin. And 2, 1x is first, so we go out 2. And 1 is second for y. So that's the ray there. Out you go. That's the ray that's going through 1, 2. So we've got a side x of 2 and a y of 1. So what is the angle of this ray in the positive direction with the x-axis? So we're looking at theta, 0, 0, and x is 2, y is 1. So is it a variation of our exact values trig? Okay. So 2 squared is 4. 1 squared, 4 plus 1, so it's root 6. So 2 squared is 4, so it's root 6 on there. Just trying to see if it's a divide by root 6. Root 3 on 2. So we would be able to write, 1 squared is 5, isn't it? Not 6. 5. So that's our angle. So that's all right. We can do, okay, so we can just do it as sine. So sine is opposite over hypotenuse. So sine theta is opposite over hypotenuse, so it's 1 over root 5. Cos theta is adjacent over hypotenuse, so it's 2 over root 5. And tan theta is opposite over adjacent, so it's 1 over 2 for that particular angle. So that's how without a calculator idea. Well, that's not quite what I would do, but that's nevertheless okay. So a ray passes through 0, 0, and so it's just getting you to do Pythagoras and getting you to see the size of the triangles. Okay, so 0, 0 again. This time we're going for -2 in our x direction and 3 in our y direction, and that places this up here like this. Okay, now that's in the second direction. Y is positive, x is negative. So we've got -2. So what's the hypotenuse? 3 3s are 9, plus 2 2s are 4. So r is equal to x squared, the square root of x squared plus y squared, which is the square root of -2 squared plus 3 squared. Putting the brackets in. So 2 2s are 4, 3 3s are 9. So we get 13. So that's our radius there. Square root of 13. And our angle sits in the nape here. So it's just asking for that. So the triangle itself has these proportions. So we're looking for root 13. 3 is the y and 2 is the x. Doesn't matter if it's -2. So we'll just go for sine, cos, and tan. So sine is opposite over hypotenuse. So it's 3 over -3 over root 13. Okay. That's 3 over root 13. Cos theta is adjacent, so it's -2 over root 13. And tan theta is opposite over adjacent, which is 3 over -2, which is -3 over 2, if we look at it like that. Okay. And we can do another one. A ray passes through the origin, -2, -3 this time. So that's the way that we would draw our triangle in our exact values trig. Okay, -2 and -3. So if we find out the radius squared, it'll be the square root of -3 squared plus -2 squared, which would be the square root of 9 plus 4, which is the square root of 13 again. 13. So we've got -3 and -2 for our sides. So looking at this angle, sine, cos, tan. So sine is opposite over hypotenuse, -3 over root 13. Cos theta is adjacent over hypotenuse, that's -2 over root 13. And tan is opposite over adjacent. And because it's -3 over -2, it's just 3 over 2. Minus over minus, and they cancel. Okay, so the quadrant questions again, coming up as they do. So we'll just name the quadrants here. So 1, 2. This is this old school thing, isn't it? So what does that mean? Where is sign positive? Sign positive. Okay. And cos is negative. So y is positive. This is the association. And x is negative. So where's y positive? Y is positive here in this quadrant. So it's quadrant 2. So we'll write 2. Cos is negative, so x is negative. And tan is positive. Now tan is positive, which means x and y have to be the opposite. So if x is negative, y has to be positive. In order for tan to be, because if y is negative, negative and a negative make a positive. If y is positive, it'll make it negative. So it's got to be, y has to be, in order for this to be a positive, negative. I think I said that wrong, but I hope I got it right in the end. So where is x negative and y negative? In this quadrant here, quadrant 3. Okay, so in the third quadrant, 1, 2, 3. All right, cotangent and cos, so x is negative. So where is x a negative? So it's this direction here, 2 and 3. And cot is negative. So cot is negative means it's the reciprocal of tan. If the reciprocal of tan is negative, then we would need tan to be negative, which would mean we would need y to be positive. So x is negative here, is x, and y is positive here. So negative and positive. Okay, so that's quadrant 2. Back to quadrant 2 for that one. Alright, so through the lens of exact values trig, this is something that's quite doable, I think. Okay. In each of the following, replace the given angle with an acute angle. So what that means here is that cos 160 has an equivalent angle. And we've seen this in a way. So cos 160 is going to be like this. Okay, cos 160 will be that angle there. That's cos 160. Now, in the exact values trig, what we understand is that there will be an equivalent angle here. Okay, an equivalent one. So what is it? So if that's 180 and that's 160, this angle here is 20 degrees. Okay, so this will be 20 degrees. So it's not cos 1, it's not cos 20, and why isn't it cos 20? Because cos 160 has x as a negative. That x there is a negative. So we can't just say cos 20, because cos 20 is a positive. X is positive. So in order to make that a negative, we need to put a minus out the front. And so it will equal a negative. So minus cos 20. Cos 20 itself has the same length of x, but it's a plus, so we need to make a minus. Okay, so that's all that's happening there. Sine 220, 180, 225, so it's about here. Sine 220, so the angle's going all the way around like this. There it is. Sine theta, sine 220. Now 220, y is negative. Negative, and x is negative. It's referring to sine, which is y. So we might not need to do anything here, but we may do. All right. Now this has got an equivalent triangle on the count, doesn't it? So the equivalent triangle would be up here, diminishing triangles. And what's the angle? So if that's 180 and that's 220, you've got to go 20 more to get to 200. So that's 40. That's 40 in there. So 40 degrees. Now what's the problem? This sine here is positive. So how do we make sine 40? Sine 40 is positive. So how do we make it negative? Well, we multiply it by the minus. now we've got the same as this one. The y's are the same. So it's minus sine 40. So the exact values trig diminishing triangles works however you want to do it. Okay. So this one here is tan 189, so it's just past 180. It's a little triangle down here like this, and it's got an equivalent up here. Okay. It's got a negative x and a negative y. Minus times a minus is a plus. Oh, very good. So 189 means that that angle in there is just 9 degrees. But because minus times a minus is a plus, we don't need to change anything. The tan of this will be a plus over a plus, rise over run. So therefore, it's just tan 9 degrees, taking into account the polarities. It's easy when you count around. Okay. Now cot 340, let's have a look at cot 340. I better just label that one. What was that? Tan 189. All the way around like that. Okay, so tan 189 and cot 340. Now 360 is all the way here, so it's something like this, which means it goes all the way around here. And guess what it's got? It's got an equivalent triangle here in the positive. So what we've got here is a negative y, and we've got a positive x. A negative y and a positive x, and that gives us cot 340. 340, oops. Now cot is a ratio of y over x, so x over y, it's tan. So tan is rise over run. So x, cot, is x over y, but that's not what's important. What's important is whether they're minus and minus and plus and plus. So cot 340 is x is negative and y, x is positive and y is positive. So overall, it's a minus. Okay? So it's a minus. So in order to maintain, now if we do cot up here, it's a plus y and a plus, so we don't get the right thing for cot. What's the answer there? 20 degrees. Theta would be 20 degrees. Okay, so cot 20 degrees is positive. Now tan 20 degrees is positive. So in order to make it a negative, we need to put a minus in the front. So we just make it minus cot 20. So now they're the same. They're equivalents. Okay? That's all that's happening. We're just making equivalents and just analysing what's happening to x and y. Now, sec 350 is again all the way around. So sec's an even narrower angle. Okay, narrower angle for sec, but it's got an equivalent there. I've exaggerated both of those. I think I'll try again with both of those. So, just put it like that, and that'll be the same thing. And so this angle here is sec 350. Now sec 350 is 1 over cos. Just looking at that, 1 over cos 350. So the reciprocal nature doesn't change the polarity. It's only whether or not they're tens or whatever. So in this case here, y is negative, but x is positive. X is a plus. So whatever we put there should also be a plus. Now this little angle in here now is 10 degrees. Okay, so cos, it just so happens that if we do sec again, okay, if we do sec again, then sec 10, we don't need to change it because it's positive. Okay, because we're looking at x. We're only dealing with the x component. Cos is x, remember. So we're only not looking at that one in this particular problem. So we can just do sec 10. All right, so we've got the same ones throughout. Cos, cos, sin, sin, tan, tan, cot, cot, sec, sec. Yeah. Do the same as in the previous question and evaluate without a calculator. Oh, very good. Okay. So these are our exact values trig. Because cos the complement was 20, so this would be minus cos the complement to 80, 60 and 180 was 20, so 150 to 180 is 30. So let me dress them up first. Sine 240 to 270 was 220. Now it was back to 180, wasn't it? So it was sine 60. So it'll be sine 60. 60, 240 take away 40 is 200, take away another 20. So it's sine 60, but it's a minus. Okay, and then we've got tan 120. So tan 120 is going to be, it was 189, so it was 180 was 9. So tan 120, 80 is, oh, well, it's two lots of tan 60. So it's okay, we don't even need to check that because that's two lots of pi on 3. Okay, so tan 60, I'm going to have to draw it again. Oh, so I'll go back up here. No, I'll do it on separate set. Okay, so we've got cos 150. So 150 is 30 short of 180. So that's a 30-degree angle. Cos is the x. Okay, cos is the x, and the x will be root 3 on 2. Okay, and it's minus root 3 on 2 for our unit circles. Okay, so minus cos 30 will be minus root 3 on 2. That's your exact values trig. For the next one, sine 240 will be 270 here, 240, 70, 45, 240. So 80, 20, 200, 240, so it's about here. Okay, 240. So that looks like our 60-degree angle, doesn't it? So that's all the way around there. Okay, so that's 240. And if we recognise this as sine, we're looking at the sine values. Now the equivalent 60-degree triangle is here. That's your 60-degree part there. And the y is positive. So in order to get it, it's still root 3 on 2, but it's a positive root 3 on 2. This is a minus root 3 on 2. So we're just going to have minus root 3 on 2. Coincidence about the angles. Okay, x and y. Alright, so tan 120. Tan 120 is two lots of 60. So the base angle is 60 degrees. So that's root 3 on 2. And that's a half. Okay, so there's our base angle. There's our 120. Okay, now tan is opposite over adjacent. So it's minus a half, isn't it? So if we get tan of 120, we get opposite over adjacent. So it's root 3 on 2 divided by minus a half, which is root 3 on 2 times negative 2 on 1. They'll cancel, and so we're just left with negative root 3. Okay, so the negative root 3 for that one. Exact values trig. Okay, that's all it is. Just look at it through that lens. It's fairly straightforward. Alright, 330 is 360 minus 30 degrees. So that's all the way around there is 360, 330 degrees. But this angle in here is your base angle, it's 30 degrees. So that's the same there. That's a 30-degree triangle. Now what are we talking about? We're talking about cot, which is, again, x over, so we've got a half here, and that angle there, that length there is root 3 on 2. So the rise over the run for tan is the same thing that we just had, rise over run. So root 3 over 2 divided by 1 over 2. And so we'll flip them and everything, and we'll get root 3 on 2. But because the negative is there, minus root 3 on 2. And it doesn't matter that it's the reciprocal of tan, because it can still be cot, which is a half divided by minus root 3 on 2. You're still going to get the same answer. I'll let you work that. So minus root 3 again. Okay. Sec is 225. So we'll come here and do a 225. And that's probably just finish this question off and redo the video. So I'll just finish this one off. 225, 180. It's 180. It's 45 degrees, isn't it? So it's got an equivalent up here. And what are we talking about? 1 over cos. Okay, so that's your 225. And sec 225 is 1 over cos 225. Okay, now cos of 225 is 1 over root 2, negative 1 over root 2. Okay, so it's 1 over, or 1 divided by 1 over root 2, and so it's just 1 times root 2 over 1, which is root 2. Now remembering though, it's a negative all the way through. It's a negative, so you get negative root 2. That's all it is, negative root 2. Okay, cos 315. Cos 315 is 15, 60. So I'm just thinking about 45 again, is it? 20, 60, yeah, it's 45, so it's this one here. So same widths all the way around. Cos 315 is looking at the x. Okay, the x is 1 on root 2 positive. Cos 315 is 1 on root 2. Okay, so the equivalent is just going to be this one up here, which happens to be the same thing, which is 1 on root 2. So the answer is 1 on root 2. So just if you've been paying attention for the last 5 weeks, that question made perfect sense. Okay, and it's really important that you spend time doing it, but there you go. Okay, alright, so I'm going to stop the video there because that's 28 minutes, and I'll be back soon with the next part.